Today we'll discuss quasi-experimental design. The term quasi means resembling, so they resemble experimental design in some ways, but they're different. They usually refer to an experiment that is done without random assignment to groups. That's one of the major differences. They do not definitely indicate when a change in one variable causes a change in another variable. So this type of research, we can identify likely causes of the outcome, but not a definite cause. Causal inference is stronger in true experimental design, where you definitely have random assignment to groups, and that is supposed to lead to equivalent groups. So the groups, a control group and a treatment group or experimental group, should be similar before they start their experiment. There are some authors who group together 4 different types of design as quasi-experimental. I'll warn you that a lot of people don't just put them all together and say these are all quasi-experimental, but Rosenthal and Ray in their textbook, they do call non-equivalent groups design, time series design, single case design, and correlational design. Those are 4 types of quasi-experimental design. Here's an example of non-equivalent groups design, so you can see what it looks like in a notation form. You'll see that there's a treatment group that's not randomly assigned to receive some observation, some event or stimuli or treatment, and an observation again. At the same time, a control group, or similar time, is not randomly assigned to be observed, not have the treatment, and then have an observation after a lack of event. In this notation, notice that NR refers to no random assignment to groups. The O refers to the observation, and the X refers to the event. There may be several reasons why one would not be able to do random assignment. Now, in this type of non-equivalent groups design, one group experiences an event or treatment and another group does not. So the group that does not receive the treatment acts as the comparison group. Let me say that one more time. One group experiences an event and another group does not. So the second group is the comparison group or the control group. And again, observations are done before and after the event. I'm just reading this again to make sure you really get this. Researchers determine whether the treatment group is different after the event than the control group, and they check whether they were different before the event too. So this design is called a between subjects design. There's several types of control groups. We can use these in true experiments as well as these non-equivalent groups design in other types of studies. A zero control group, in case you don't remember this from other lectures or other classes, is a group that gets nothing. That means they don't experience the treatment or the event. They get nothing. So they usually know that they're getting nothing, as they can sort of figure it out depending on what kind of study it is. There's a placebo control group, and they are supposed to think that they're getting the active treatment, but they're expected to believe that they're getting it, but there's some reason that they don't know that they're not getting it. For example, if there was a sugar pill is a placebo because people are expected to think that it might work. A waitlist control group are participants who get a treatment after they're done participating. So for example, let's say there's a back pain study and people for some reason can't be randomly assigned to receive treatment or be a control group. They really want to deal with their back pain, so what might happen is they might be assigned to a wait list and get treatment, say, a month later, whereas the main treatment group gets the treatment that month. So at least they get some treatment, which they want usually. Another type of control group is an education control group. They receive educational reading materials or other types of materials to help educate them about something they usually want to know about, such as, in this case, you might have a back pain educational control group. They don't get the particular medical treatment that they might want that the experimental or treatment group gets. They get this reading material. Now, a reminder, there's no random assignment, and this might be because it's impossible, difficult, unethical, too expensive, or beyond the scope of the study to randomly assign subjects to experience it. Now, some health, clinical, and environmental psychology research do research after disasters. By the way, there's a box here just because I don't want you to read too much while I'm talking. I think it would be helpful if you just listen. When you do research about disasters, you don't know when it's going to happen or who it's going to be affecting, and you can't randomly assign someone to be in a disaster and see how it feels and have other people not. So you have a control group. So you have to go and find people after the disaster and then ask questions of them that are interesting to you or important to you. For example, you might ask how they're coping, and you might see what kind of people cope well after a disaster and what kind of people do not cope well after a disaster. By the way, I think I've heard some research assistants who work with people that do this kind of work call it disaster chasing research. But it's very important work, so we can help people understand how to get through a major stressful event. And the kind of work they do doesn't just work for or explain the natural disasters or man-made disasters, but also any kind of major stressful events in some cases. In some cases, the disaster itself matters. The type of disaster matters. In some cases, it doesn't. It depends on what we're looking at. Well, let's take a look at, or talk a little bit about one type of research that's been done on nuclear power plant problem. So, not too many years ago, there was a nuclear power plant breakdown in Japan. People wondered a lot, how do people respond? And I think there's been some research on that. There's more of a classic research on a power plant explosion, I believe. I should check whether it was explosion or a meltdown or what happened. But at 3 Mile Island, I believe that's in the U.S., or at least close to it, there was some people who were affected by this in an area. They experienced some treatment, and some people who do not. The people who did not were in a similar area, and they were in a control group. And researchers would look at them, look at some of their data before and after 3 Mile Island problem, and they'd look at the people who were there experiencing this meltdown and see how they differed. One of the things that they were looking at is, how does a man-made disaster, such a major stressful life event like that, affect relationships? How does it affect families? And they found that the group that experienced this major disaster experienced more divorces. So people were ready to leave their spouses after that. And there's more to that, but I can answer that question to anyone who finds me. In some textbooks, you'll see some examples of quasi-experimental research and epidemiology and food poisoning. So if you're in my course and you want to read a little bit, it's a good idea to read this part of the book about food poisoning and how people sometimes go about finding out what caused someone to get sick and what caused several people to get sick. So I've worked with some epidemiologists before, and I've seen some of what they do. I can tell you more about that another time. So at Orange County, there were some epidemiologists on TV, and there was an illness outbreak, and they studied who got sick, who experienced the event of it, where they were, and what they ate, in order to figure out the treatment group who got sick versus a comparison group who didn't, and try to figure out what the cause was. Now, data is collected in a different type of design, the interrupted time series design, also quasi-experimental design, at several points before and after an intervention or a naturally occurring event. So the event is considered an interruption or a treatment, just like in the previous design I mentioned, and there's no control group this time. So it's a within subjects design because you're looking at the same people over time and just one group of people. So let's say the people who were studying 3 Mile Island wanted to just look at people before and after the disaster who were in the affected area, who got their treatment. They would assess divorce rates, let's say every year for 5 years before the nuclear event, and let's say 5 years after the event, and then see if divorce rates were lower. Okay. Another example is researchers have estimated trends in smoking prevalence in California before and after a bill is passed that prohibits smoking in public buildings. So they look several years before or some amount of time before, then there's a law that's passed, and they look at what happens after. And then they see, okay, did people smoke less? And in many cases, in many types of laws that were passed, they did smoke less. Now, one problem with this kind of design is you don't really know for sure if that is actually the cause, if the cause you think is the cause is. It's possible that there might be a major television campaign or public health campaign to prevent smoking. So that might be the cause, that there's just suddenly that year a lot more information. It's in the schools, it's on TV or on screens, it's in perhaps major sporting events. There's a lot of ads to say, hey, don't smoke, and here's why. So that can happen where it looks like maybe it's not just the law itself, but these other things. Now the notation for the notation for interrupted time series design is like this. So you might have, let's say, 5 observations before some event and then another 5 observations. Again, remember that there's no random assignment. There's only one group, so you can't randomly assign people to different groups. There's just the one. I'll stop here and we'll start another set of slides.